Okay, good morning again. I think we can start. So, this is one of the initiatives that we have taken up to have open, free discussion on anything that the community likes to discuss about. We have had some very good sessions where we had a very high level of interactivity, and it sparked many other discussions and side discussions and follow-ups on our chats also. So we really thought that coming together and talking in person and clarifying things, knowing the new things in the language, better ways, better tricks, good practices, and even beyond C++, anything about your systems, any problems that you face. Um, be it it could be anything. So I'm not suggesting anything here, but what I'm saying, this is the whole reason that we thought we can come together and have some open and free discussion. So as you know, is with free and open discussions, there is no agenda. So does anybody want to start or raise a topic, anything about the standards, anything about any new constructs, or where we are going with C++ or whatever?
Hi, I'm good. Can I go on?
Hi, yes, please.
Uh,
Most welcome.
Hi. So this is John again. So I just want to know, like, if anyone is using C++20 in their like production or development code base. Uh, no,
No, no.
So
okay.
I have tried a lot to upgrade the compiler to the latest one.
Okay.
But as you know, C++20 is not yet available with many compilers. Nobody is complying to it yet. So in a year, we should see that. So there could be some moves to recent compilers, but it's not yet happened, at least at my place.
Okay.
I guess the
Okay.
reason is C++20 is actually pretty huge if you look at it. Because let's say the jump from O3 to 11 was huge, so compilers took quite a while to take time to conform to C++11. But 14 was relatively small, 17 was big but not that big, so the compilers caught up by the time standards was published. But this time again, it's very huge, so I think we'll take a year or two to for the compilers to iron out all the bugs and implement all the features.
Yeah.
Yes,
Well,
and
like.
just to add on that, people in production, they don't want to make mistakes. They want to learn from other people's mistake and then implement it. So until and unless the community which is kind of driving, for example, the teaching community, and that they start using this modern feature, gives recommendation on how to use, what not to use, best practices, it will take a time for everyone to adapt, at least the new features like modules or contracts or all these features.
Yeah, like particularly the new features are very impressive, like the coroutines or the concepts, which sometimes we have to try, have to like, we can achieve so much more with constructs instead of going for the template-based one that we currently have. So that's what I have this question. So because when I'm like creating libraries and stuff, I like did kind of miss that, and that would make my job a lot more easier and make the code a lot more, I mean, cleaner. So that's why I put up this question. But yeah, as Ankur said, compilers is a real thing that is holding me back from adapting. Yeah.
So just one thing I just wanted to add to this was uh,
Can anyone hear him? I can't.
No.
And
I
I cannot
think,
hear you.
yeah.
I think Ankur has to reboot his system.
Okay.
Okay. Does anyone want to put some more thoughts on this?
I guess we should go on.
Amaya, do you have any question or any new topic?
No, just like that for C++20, I think so it'll still take some more time because like if you like all the other features, like they're still getting worked on, right? Lot of different like even like the C++ modules, coroutines, you know, other features that's there in the plan. So I think so those things are anyway getting developed differently in at least in compiler side. So that would still take time to get it integrated into the mainline kind of stuff.
Yeah, yeah, right.
I think Mo had wanted to talk about STD atomics and STD condition variables. Given that no one has anything else, I guess we can start from there.
Sorry, were you, what were you saying? I couldn't hear. Hello.
I was saying that in my last presentation, Mo wanted to talk about STD atomics and STD condition variable. And if no one else has anything to talk, I guess we can start from there.
Okay, yeah, that's good.
Yes, Mo, are you able to hear us?
Yeah, I guess if I guess I could start. I guess how many of you are familiar with atomics?
I am kind of familiar, not exactly.
Yeah, I
Kind
know
of.
I know the concept, but I don't actively use it in my code.
Yeah,
I
like,
know it from like hardware perspective that how it matters and that, but I haven't used in like C++ atomics in that.
Yeah,
so
same here. Same here.
I kind of used it somewhere, like for log-free programming and stuff, to basically deal about this memory, like memory or and stuff. So yeah, but it's not something that you pretty much use in everyday code. But if I have to write some containers with it, I usually keep it inside there.
Yeah, I mean, see that I've only used it like a few times. Like one was for like I guess you could call it like a lock-free depth first search, breadth first search. I was doing like a side thing. It wasn't like a production code or anything, but as opposed to like using locks, to lock a special cell or a node or whatever you want to call it in a graph. I just had to use atomics. I decided to try atomics. It worked out fine, but and it was a little bit faster than using locks, but not like not by a huge amount or any significant amount. So I don't know, but the thing with atomics is that maybe I was reading a bit, and it seems like it's not necessarily faster than a lock, because if you only have one lock and it's you decide to place it in the correct position, it might be actually a lot faster than using atomics.
Yeah.
Because I mean, under the hood, I guess atomics really is it's an atomic operation, but there's still some mechanism that's kind of I guess I don't want to say locking, but it's kind of locking and doing everything in one single atomic step. But I mean that's not really how I should be thinking about it. But that's so far that's how I've come to think about these things.
Yeah, I mean,
Herbst has a great talk on this lock-free programming in C++. I guess in CppIndia 2014, and he says this that lock-free programming doesn't mean wait-free programming. Right? Wait-free is things happen instantly. When you do atomic operations, most of the time you still got to wait. So there's like really you are not trading in much performance.
Yeah, that
yeah,
sounds
I mean, it deals with this memory data results and like the read-write operation, right? So you either like release the memory or like, consume the memory, and so most of the time, if you're just going to let's say have a boolean variable, and that is going to be accessed in multiple threads, you can just have standard atomic. But if you know for sure that it is going to be used only for read or write in a particular location, then I think you can extend that better. Like, you can use like maybe like standard memory or memory release, those things, and it might give you a little more performance, provided that you know if it is read or write operation. So I think in that instances, it is it can give you a little more upper hand than Unix. I think. Yeah.
But one thing very good about std atomic is that it encapsulates the logic that this variable might be accessed from different threads. And so it for me it's basically log the variable automatically every time I access it.
Yeah, that's what I said. So on plain simple terms, you just use standard atomic. It just do fine. But if you want to dig more, and then if you know whether how the read is happening, how the write is happening, basically how your data is being read or written, then I think you can do much more with standard atomic, and then you can use the memory order to release or consume the particular variable or the memory. But I think in most cases, standard atomic will do this well.
Yeah, see, that's one of the things with atomics. When you really get into it, I think to get the best performance, you have to try to specify the memory model, and that's something that I haven't really, I don't really understand how the differences between all the memory models. But I guess to really get the maximum performance, you have to kind of dive down that rabbit hole. And has anyone used atomics? Not necessarily in production code, like just like in a side project or anything?
I guess you have the answer.
Yeah,
I've used atomics in production code.
Oh, in production.
Yeah.
What was it? Just a general view. What was it that you were doing? What was it that you were using them for?
It was so one atomic was a flag indicator whether a child thread should continue anymore or not. So there was an application which was doing the main job, and then there was an update thread. So when the main application wanted to exit, it wanted to communicate to the other thread that it should stop doing its job. No more updates are needed. And so there was a flag which was used there in order to indicate this to the other thread. This was the most immediate thing which I came across in this week. Before this, I've used atomics in some REST related code, but I don't really remember. Maybe I can try recalling if I get it. I'll tell you.
The first one looks like it's a good place for
but more often than atomics.
Yeah, that sounds about right. I mean, you're basically what you're saying is you're using atomics to shut down the child thread safely. And I guess you're by shut. I guess you're joking.
I had a bad audio, maybe bad.
Oh. Can you hear me? No, I think he's got some lag.
Yeah.
Yes, Mo, I can hear you.
Yeah, I guess what I was saying was that's kind of how I've looked into atomics, just using them for safe shutdown of child threads. I'm guessing in production you don't want to use detach, so you just wait for the threads to join at the very end, but you kind of signal to it by toggling the Boolean. That's one way you shut down threads. I guess the other ways I've done it was using futures and promises, which I think we might have covered in the previous talk.
Yes, I guess some could have. I guess he's just having a bad internet connection.
Yeah, I think so too.
Hello.
Yeah, I just wanted to add that yes, it was indeed for just a flag, and it was indeed an indicator. We did have a condition variable also in order to signal to the other thread explicitly, but there were other reasons that you also would want to stop the update. So you don't want to exit altogether. So there was this combination of the bool and condition variable, which I came across in this week sometime, that was used in our code base. I don't think it's ideal, but I guess you guys were talking about lockless implementations, maybe when I was having some struggle with my audio.
Yes.
Yeah, so the thing about lockless, they say is prefer not to, because it's not worth and it becomes very complicated. And so they say many people, I guess Hemil mentioned about Herb Sutter, Tony Van Erd has talked about it, and even I guess a couple of more other people have said that lockless, it's not something to it doesn't solve many problems. It doesn't really lead to weightless logic. It would still be a lot of handling has to be put in place with a lot of correctness. So if you do it yourself, it's a very difficult problem to solve.
Plus, it's only applicable when eventual consistency is good enough. Like if you want instantaneous result, then you need to lock the thread to you need to lock the variables to get the instantaneous values.
Yeah, that's kind of what I've gathered by listening to some talks and talking to other people. It's that lock-free programming in general is not an easy thing to do. I don't know. I don't think I've heard anyone actually do something like that on their on their day-to-day job. Although I guess there's probably some libraries out there that have already implemented some lock-free data structures, but that's an area I'm not really familiar with. But go ahead.
I think Shriram wanted to add something.
Yeah, I wanted to say that I also used atomics, and usually it is about sending a flag, sending a signal to the other thread. Nothing elaborate. Um, but I've seen sometimes if you combine two atomics together, that means probably you're doing something wrong, and probably you should have a lock. Now you have a race condition, race not a race condition. Um, there were two terms, right? Race condition and this one race, data race. Yeah. So the difference between race condition and data race is that data race is a not what is that undefined effect.
Undefined behavior.
Yeah, undefined behavior, which means that your program is wrong. So if you put atomic on top of it of a variable, it will uh, start having a defined behavior or not having a undefined behavior, but still your program could be wrong because you might not have prevented race conditions from happening, especially when you have two different variables, both atomics. You might be changing one, you might be changing the other in quick succession and expecting some results. So if you're just having one variable being shared across threads, it might make sense. Another point about atomic is also about the contention. So uh, if you're using atomic as a lock, you can use atomic as a lock. You can do things like while some that variable is true, just pause at that place while loop, and then once that happens, then you go on to your next section. So only one thread would be able to successfully pause at that point. Um, and go into the other thread would go into the critical section. But if you do this, then you it's possible that if there's high contention, then you'll be consuming a lot of CPU. So if you want to use atomics, you need to ensure that also that your contention is very low. You're very unlikely to have two people coming into the same section, and that's the place where you get the performance. So you know that your contention is very low, so you quickly do something with the CPU, something like a lock with the CPU instead of going all the way to do the locking. So you do it in the CPU itself. It's usually implemented as an instruction, compare and swap instruction. Um, so you know that there's no contention, so you would um, not pay the price of high CPU usage. So these are some of the thoughts that none of these are concrete thoughts, but these are general thoughts that I just wanted to add also.
Yeah, I agree. Once I was programming an SFML game, and if someone has used SFML, there's a particular condition that you put in a while loop. That I got that condition wrong. I put while true inside that, and when I launched my application, the CPU usage was like 100% consistently, and then I was like something is wrong. So like yeah, while with the condition, atomic condition is not a very good idea.
It's only a good idea if you know that there is no contention.
Yeah.
Well, I mean, you could still have it, but in that loop, you'd have some condition variable. Yeah, I mean, and that condition variable has a predicate, so that way there isn't too high lock contention, and the thread essentially goes to sleep. And it's only when you get a notification does it wake up and check the predicate, and if the predicate's true, then it attempts to lock and go on. But I mean, I think what Sriram was trying to get into is I'm not sure, but do you have any experience with like potentially like pegging a thread to a specific core, so as your threads aren't you're not spawning threads on you're spawning threads on specific cores. That way, it's a lot faster than not having control on it.
Well, I have not experimented so deeply with concurrency such that you might want to pin your thread with a CPU, right? Is that what you're saying?
Yeah, like peg it to a particular like core on your CPU.
Yeah, no.
That way,
So,
when the thread sleeps, it doesn't get used by another process.
no, I have not really. I've heard of what such things, but not really done anything even remotely like that.
Okay.
So we have some thread pools, generic thread pools and all. So within our ecosystem, we probably could have used a third-party library. So you can see in that piece of code a few atomics scattered here and there, and a general reader of the code might not even know whether it is correctly used or not. Yeah, we were also discussing something about after atomic, we went to some other topic, right? What was that topic?
I didn't write them down, but we probably talked about other things.
About
Maybe
what?
on Discord. Maybe on the Discord channel or something.
So, guys, I wanted to ask, um, if you guys work on a pretty modernized code base, or are there your own tips and tricks to move towards modernization of code?
I mean, I think like our standard right now, the one that we're working with is C++17. But yeah, I think modernizing the code base, we use Qt5 for now, but modernizing the code base to C++20 and Qt6, that's gonna take a lot of work. But I guess it could be worth it depending on which C++ features can come in handy. I mean, I was working on some problem and I thought that std format was already implemented in like C++17, but it's a C++20 feature. So something like that could come in handy, as opposed to having to, look online for some third-party library and start using that one. But and I think while we're on threading, I think there is a new concept with std JThreads. Has anyone looked into that, or can anyone explain that? I've heard of it, but I'm not quite, I didn't really read much about it.
JThread is basically an RAI wrapper around thread. It basically just joins on instructions. So you attended my last session, right? We were calling thread.join on all of the threads in the vector. So what JThread does is, if you have a vector of JThread, you don't need to call join, because when the vector destroys, it will destroy all its member threads. And when the JThread destroys, it calls join. So it will wait till the result is available.
So you're saying we don't really need to notify the thread when to shut down?
No, say if, for example, if you are starting a one-off thread that you just want to do this piece of work asynchronously and come back, I don't care about the result, right? And then you just launch a thread and you don't need to join it. So when the scope of the thread variable is over, it will automatically join the thread.
Okay. So it's basically doing the join for you.
Yeah.
Well, I guess you still need to, obviously, you still have to communicate when that thread should shut down.
Yes.
Okay.
Yes, I guess in C++20, I guess we are going to have something. We are now having the cancel token with the threads. So you can ask for the thread to be canceled, and the thread is responsible, and your code in the thread is responsible to keep on frequently checking this cancellation token. I don't exactly remember the mechanism, but there is you can get the cancel token and then inform the thread that it is being cancelled, so that it should exit now.
One quite convenient piece in the cancel token is that you can pass it to condition variables, and the condition variable will wake you up with that cancel token without you having to write extra code around it, which is good. And I did not attend the previous conference that we had, but I did see the YouTube video, and it was quite good. And there were a few things. Maybe we can, if some of those items are still open issues or open things, then we can still discuss them. Like, was there a question? I don't remember it now. Was there? I think there was a question which asked, "What do you do with exceptions?" Not sure whether that was a question, but even if it is not a question, then if you have a future with you and the thread in which you have launched a particular function, if that throws an exception. So there was probably a question which said that, how do you handle it? And the thing is that, does anyone has an answer for that?
I guess if the thread throws an exception, when you call future.get, it will throw the same exception again. So what
Yes.
happens is, if the thread throws an exception, you can put a try catch block around the get function, and then you can handle the exception over there. Or you can design your thread in such a way that it internally handles the exception and returns an error in the future.
Yeah, that's correct. Probably I was not paying much attention last time, but I thought that there was such a question. And yeah, what you just said is uh, correct.
Yeah, I don't think there was a question. I guess I just explained that future.get might throw. So if there is a thread that is the action that you're doing in a separate thread might throw, then
Mm-hmm.
you prefer to put like a block around it because get can.
Mm-hmm. Right. And were there any further open questions or discussions in that, or
I guess you can just ask.
I don't remember it. That's why. Anyways.
I don't remember.
I mean, most of you are most of you allowed to use exceptions in your production code. I thought that was a big performance problem.
Can you repeat?
Yeah, in our production code, we use exceptions liberally. Um, but there was one time when 10, 15 years ago when I was a junior developer. So what I had done was when the connection failed, I would throw an exception, and then I put that into production, and suddenly people started complaining that it's very slow, very slow. The entire code has become very slow. And after debugging it for quite a while, I figured that every time it tried to make a connection, it would fail, and that would cause a lot of overhead. So then I had to change that code to, instead of throwing an exception, to return true or false and handle it that way. And from that point onwards, I would always think while trying to throw an exception, I would think whether this is a normal thing or whether it's an exceptional condition. Like I remember boost lexical cast. There's a thing called boost lexical cast. It throws an exception if if the number is not convertible, it'll throw an exception. So I don't know whether that's the right thing to do. I can't tell you whether it is right or wrong. It's all subjective, right? So I feel that that's not always correct. On the other
I think
hand,
n- n-
yeah.
most of the times we developers use the exception so as to make sure the process does not crash. At least that's the main reason I do use exceptions in my code. We don't use it quite liberally, but yeah, like if I know for sure like this method is gonna give an exception, and in my code base if an exception is not caught, the whole process crashes.
Mm-hmm.
Yeah, generally, I think the way I think how in C++, uh, generally, if you are trying to throw an exception, I think it is supposed to be an exception. It is not supposed to be a normal way of doing the thing. Like if you have a function, and then if the function is expected to return a false value, you don't throw an exception because, like let's say in some languages like Python and Java, throwing an exception is a way of developing the program. But I think in C++ that is the more advanced way of doing things. You throw an exception when it is really an exception and it is not anything that is expected in the normal behavior of the program. So we can be handled. So that is my rule for using exception. I'm going to use exception. It should not be the normal flow of the code. Then it has to be something undefined or
If you look at this boost ratio library or even the file system library, uh, so as a library, you do not know where your code is going to get used and whether it's going to get used in a critical section or in a some other place. So the designers of these two libraries have gone to the extent of muddling up all their interfaces, providing two functions, two overloads for the same action, one which will take error code and one which doesn't take error code. If you don't pass the error code, then it throws an exception. So uh, it's good for performance, but the interface is like so confusing that you have so many functions. And the herb searches static exceptions tries to simplify that. And I don't know when none of herb's um, fancy papers. I don't see it moving around very fast. Like he's always anyways saying that it's going to come in some future number, right? C plus plus 25 or whatever. So, so some of those papers are very exciting, and including those the um, I forgot the name of the paper. It's about using constexpr onto the meta classes. Yeah, the meta classes thing. All of those are very exciting things, but I don't know whether we are ever going to reach there.
I'm sure we'll reach there actually. In fact, we started in C++11 with context for one-liner only. Then we could extend it
Yeah,
to more than one line. Then loops were allowed. Then your other object types or something else was also allowed. Um,
yeah. Then
Templates is evolving to hold
exception
on to object.
exceptions were allowed, but not really in runtime. But you can still have
Yeah,
in the
If your code doesn't throw, it will compile.
yeah.
exactly.
If
Yes.
it throws,
If
it
it did not
finds a
throw,
comparison
right,
error. Yeah,
right. Yeah, exactly.
and
So
in
I'm
I
sure it
guess
is getting more and more relaxed.
yeah, in C++20, I think they allowed new expressions. So you can now have a static vector or something like that, which will allocate. In fact, I don't remember exactly. STD vector is supposed to be constexpr compliant, right?
Yes,
The-
but I tried playing around with it, I guess a month or
yeah,
something ago, and I don't think compilers like
yeah, compilers are not there.
compilers have not supported it yet.
Uh,
Like there are trunk which support
yeah,
it, there are branches which do, but the stable versions don't. So
yeah,
I guess it will take quite a while to adopt.
yeah. And personally, in production, constexpr plays a very small
So if
role.
you if,
Two functions are constexpr. Nothing else is constexpr. What's your experience in usage of constexpr? Have you guys used constexpr for something critical?
I have, I guess,
Sometimes,
I was
yeah, sometimes if you use
earlier.
constexpr, you can like test it. You can just static assert and then test the cases, and then you kind of know that it's pretty good. And
Yeah,
we can
essentially it is very small bits,
yeah,
pieces of code. So sometimes
yeah.
I wonder, though it's a great feature to have,
So actually,
how much benefit are we getting out of all that extra facilities? Now C++20 added const eval, which is like saying that this should definitely be const expr. The words are all wrong. Const expr actually means that you can invoke it at runtime as well.
you may.
Uh,
Yes, yes.
Well, in C++. So when codes that shouldn't be run at compile time.
yeah.
Uh,
So I guess it's useful if you're like crazy about optimization. Last bit that you want to extract out. Maybe at that place,
Well, yes,
useful. Yeah.
I would like to extract the last bit out of my running processes and my scores. And In fact, in this week and last week, I was working on some performance enhancement, etc. So I would love to have that. But to be honest, I'm in the telecom domain. So I don't know that your call will be coming in at 11 o'clock and joining this particular meeting. I don't know what I can handle at compile time, right? So if I am writing a telecom product, telecom software,
Yeah.
which is dealing with things at runtime, and which I guess many of us, you don't have much to do upfront. So even I look for a lot of cases where I could actually use constexpr, but I don't find many. The one part connected to telecom, I'll just complete what I'm saying. One part where I see something like constexpr can come in, can be very helpful is in order to create a protocol parser from the protocol grammar, what we call as ABNF, which is a description of the protocol, and
Right.
I could give that text definition to my program, and I could expect a compiled C++ version of it. So there are commercial products which do this for ASN1 parsing, etc. But but they provide empty functions, etc. So that's one use that I can think of, and I have not yet got to it because I see there's a big, personally, a big jump that I have to do in order to even start.
Yeah.
Bala, do you
The
have library?
Hannah's regular expression library. That is one example of that, right?
Yeah, Hannah's, yeah, that's lovely
Yeah.
actually. It was
Yeah.
so exciting when she presented it for the first time. Have you seen her
Yeah.
first video where she presented that?
Yeah,
Yes.
yeah.
It
I've
was
seen all of the
3 minutes.
videos.
Okay, you have. It was 3 minutes, 14 seconds of quick blabbering, and she goes away without stressing much points. It was so developer-like.
Yeah. And she has that cool thing that on the presentation, live presentation mechanism, where she types in the regular expression. See that
Yeah,
grammar.
and the automata
Yeah,
How to
automatically.
do that?
Yeah.
What library or how do you create such a presentation where it is?
I have tried to search it for such a long time, but I have never been able to find a solution for it.
So does it require a server to be running somewhere and I type it and
I guess it, I guess
what is
for
that really?
JavaScript manipulation, but I might be wrong because it is extremely complex because you need to care about placing where the objects are there, and you need to care about the
Yeah,
window size and what text you have, and it gets
yeah,
complicated.
yeah.
What are we talking about here? Can I didn't catch that?
We,
Have you seen Hannah's CppCon presentation, the full 1 hour length?
I'm sure I have, but please tell me what you're talking
So,
about.
what in the presentation there are sections where what she does is she's typing the regex, and there the slide actually constructs the automata. So if you know about the compiler theory, regex is basically a string version of a pictorial representation of an automata. So what she does is she types, and the slide automatically changes and it displays the automata pictorial, and that was very cool.
It
yeah,
was a really dynamic.
Yeah.
She was
yeah,
inputting, and
Yeah.
yeah, in the slide itself, not on some software or something else. It
It
was
was
in the
very,
slide itself.
yeah.
Yeah,
yeah. And
that was really cool.
when I try to create some slide which is like having some motions, it takes a hell lot of a time to get it right. You try to right click this, do the animation once, and you have so many things that you have to check whether it is all connecting. And when you're presenting, at that point you will realize that you have missed one section somewhere. But that was so.
Yeah,
I don't
yeah.
think it
Somehow
was.
the mistakes.
I don't think it was pop, and 100% sure it was not a pop.
Yeah, even this other kind of presentation I have seen, which has this arrows at the bottom.
That is reveal.js. That is the one I used last time in my presentation over
You use that? Yeah, okay. How do you get to that though?
Reveal.js is basically you write an HTML file and it automates the slides and transitions and gives you the arrows and all that. What do you
Hmm.
are you familiar with HTML?
Familiar, just enough to.
Yeah, so what you do is HTML has a tag called section. So each slide is inside a section, and inside
Mm-hmm.
the section you can use head H1, paragraph, bullet points,
Mm-hmm.
whatever normal HTML you want. And
Mm-hmm.
what Reveal.js does is it automatically provides styles for all those components. So all my headings were H1, all my lists were unordered list OL, and the list items were LI, which are the standard HTML tags. And Reveal.js made them look just beautiful.
So you prepare your HTML and then submit it to Reveal.js, and it'll spit out.
It's
Uh,
a JavaScript framework in itself. So what you can
okay.
do is you can download the HTML file. I guess the admin will. It's there in the repository on the GitHub. What you can do is you can
Mm-hmm.
download the HTML file and open it in the browser. It will just run it.
Okay. We are digressing from C++ though. We are digressing a little bit away.
Okay.
No, Sriram, we are aware of the point. We would love we would love for you to experiment with those and present to us for sure.
Has anyone done any GPU programming over here?
Which programming D is it? I start talking about D, right?
No, no, GPU.
Yeah, I
Oh,
do
okay,
graphics
GPU, no.
Because what I was playing around with, there's this concept of this manual set, which is basically a simple function. What you do is you start from zero, and then you multiply the current element square plus some constant complex number, and you do this on and on and on, and you check if a number is repeated, and if it's not repeated, then it's not in the sorry, if it's not repeated, it's not in the manual, something along those lines. So in the end, you get a pictorial representation. And what I wanted to do was I wanted to accelerate it with my GPU. So I was looking for someone familiar with that.
Yeah, I mean, like probably you can like start with
Remote,
high school.
the only remote thing that I would do with the GPU is to use some library like, and that to under the hoods,
You
which
can like start with
directly use CUDA, for example.
yeah, OpenCL.
Yeah,
Uh,
OpenCV and such things. If you just use them, I know that it internally accelerates it and uses GPU. That's all I do.
So
Essentially, I don't do it.
I come from a graphics domain, so I tend to use this CUDA work and all these things. And yeah, it can be really useful if you have to share your compute load to GPU. Like for example, one time I used for a name-based classifier, like was doing natural language processing on more like a set of messages, whether you classify them if it represents good, bad, or bad, depending on you train the data set. So I initially did CPU and then I went for a CUDA version of it. And yeah, it's really fun. Like, can chuck in like
reason
thousand
I
of
asked, the reason I asked is I saw a lot of videos about GPU programming, and the thing in common with them was GPU is basically a SIMD core. So what you can do is you can execute multiple like in even I saw some even in CUDA you mark the thing as global, and in that if you declare an int variable, it's not actually an int, it's an actually a vector of ints, and that's the size of the vector is the number of registers you have. So I was extremely confused because what I actually wanted was like multiple. What I thought of GPU before that was like 60 cores, each doing different things. That was my imagination of how the GPU worked. And then I came to realize because the problem with that is my code has a lot of loops and if conditions and whatnot. So GPUs, I came to know that they were optimized to one thing across multiple data.
Yeah, that's
yeah,
same as SIMD, right? SIMD.
yeah,
Single
that's true.
single instruction, multiple data.
Yeah, so that was actually extremely
Mm,
confusing. So I wanted to
mm.
talk to someone in here.
Yeah, I mean, like if you have to process a lot of data, like let's say if you are have to process 1,000 messages or a record of array, and you can use GPU, like you do one process and then like, chuck it into the system. But yeah, your way of thinking has to be a little changed, and it can be a little cumbersome. Like you have to use synchronization barriers and then stuff to wrap around the threads. But I think for what you said, like CUDA has something called like CUDA streams, and you can, to an extent, group the tasks. Like for example, I can have like group 1, 2, or 3, or like some group enough tasks, and then each group should have significant amount of the SIMD instructions kind of thing.
Because
So
my data set is such that I can divide. What I'm doing is numerical calculations, right? And all those numerical calculations don't depend on each other. So what the data I have can be split up into n number of cores. And what I actually wanted to do was I wanted to take advantage of all the available cores on my system. And if I run my program right now, it will use up all my core cores, this computer's core cores. It will use all the core cores to 100%. So what I wanted to do, what my imagination of GPU was, it has 60 cores and I can use 60 cores. But it turns out I was wrong.
but if you have, let's say, for a loop, and then you are doing the same process again and again, probably some of that portion might be you can transfer that. Like you said, like you have an array of numbers, and if you have a loop, and then you are trying to do that again and again, you're like maybe like a table multiplication or something, and then I'm doing the process 1,000 times. You can do push that in that kind of something. Probably use many video processing or in that kind of an area, like so you have like I am more relevant in I come from graphics domain, so we use a lot in video processing. How to use filters and stuff, and then basically it's the same operation. We have to put it across all the pixels, so it's basically the same process. But
Yeah,
I
because
yeah
displaying something on the screen is extremely parallel. But
yeah.
what I wanted to do is independent, but not exactly parallel. Like parallelism for my case is basically the data items are not dependent on each other. So if you throw me n number of cores, I can use all those cores.
Does anyone know if vectorization is different than SIMD, or is it the same name for both?
Mahindra, what do you think, Mahindra?
I think so. It's a similar only. Like at least.
So
Hello.
I remember that you while you're iterating through a loop, you would do it in chunks of 4 because you can do 4 things simultaneously. That is what is vectorization, right?
Yes.
And can be combined with sim, that if you have a very large vector uh, and you want to do some addition across all of them, so you would combine 4 of them together because you can do 4 of them together, and then you want to do that again and again on all of the rest of the elements. So you have multiple instructions, single instruction, multiple data, as well as 4 of them chunked together. So what Himal is saying is he wants to use all the 60 cores. So if you vectorize it like 60, then you can do 60 operations together, and then whatever rest of the data that's the same single instruction which he has to repeat. I'm just thinking out aloud. I have never touched vectorization. I've never done SIMD.
The
So
problem
So
is
just to add on this, so there are these two things which people think okay, they are same, like SIMD processors and vector processors, but inside they are a little bit different. For example, SIMD processor, they might not even whatever data you are sending it to, they might not even parallelly work on that. They have multiple execution in it. So once you fetch it, decode it, then after that it will give this bunch of data for crunching, and then multiple execution unit might be there, but it's not mandatory in the SIMD case. But when we talk about vector processors, there will be a multiple execution units, and the your all data will get crunched parallelly. But in SIMD case, you don't have to do a fetch and decode, so that time you will save only, not other parts. Yeah.
Yeah, my problem was my data is independent, but everything, each core is doing different things. So what I actually need is like multiple CPU cores. And what I'm getting from a GPU is like multiple SIMD cores, which I don't want because I have different data and I'm doing different things on them, but all those things are in itself independent.
Sounds like you're doing like what you really need is multiple instruction, multiple data.
So what you are trying to do, Hemil, basically you have something kind of matrix, and you are trying to use a particular, let's say, instruction or something, and that instruction or something is independent. For example, if you talk about matrix multiplication, you can do a matrix multiplication of individual element independently, right? The result of first is not dependent on the other, and you can just accumulate it, right? So all these processors, you don't have to even go to GPU and that. For example, Intel processors, ARM processor, AMD processors, they have some SIMD extensions on that. So you can just search for what are the SIMD extensions, and they provide some C libraries, which you can directly use from this process, and they will, inside the C library, basically the code will be handwritten using this specialized SIMD instructions.
Let's say let's remove the mathematical operation. Let's say you want to find the prime numbers between 1 and a million, right? So what you can do is, for example, if you have a 4-core CPU, you can divide it into 250. You can divide 1 million into 4 different parts, and each will be 250,000, right? And then you can create 4 threads, each calculating their respective 250,000 elements. And in the end, they give me back a vector of the number of prime numbers. And after all those threads complete, I can just collect them and I can put it into one large vector, and that will be my end result. That's what I'm trying to do basically. The operations are independent, but each operation is handling different data. So I was wondering if that thing can be accelerated using GPU, because I'm doing different. I'm not doing SIMD, right? I'm using different data and I'm at different stages in all different threads. But what I actually, yeah.
No, you are still doing SIMD kind of,
It
right?
is still SIMD, right?
Yeah,
You're doing the same thing over all the ranges.
Same operation you are performing, right? On the on the different number, you are performing the same operation, right? So that's like, it's not a single instruction, it will be again a multiple instruction, but all those instructions will be a kind of SIMD type of instructions.
Yeah.
I'm not sure. I can look into if there are some instructions in Intel or something like that, and if there is some library available which will allow to use directly that. Compiler tries to do auto vectorization and converting into SIMD and that, but if you directly use a library from a vendor, then you have a guarantee that it works.
I think what your problem says is it's more like a kind of a reduced kind of a problem. Like you have a billion records, and then you're trying to split that into like 2,500 or something like that. I think you can check out standard reduce, and I think you can even use standard parallel execution in the vector. So works more like that. I think you can use that. It might be helpful. So yeah, I think even the standard library offers standard reduce in parallel execution. I haven't used that, but I think that might be useful. Yeah.
I think you can. It'd be worth a look to look into maybe like the stood parallel algorithms. Maybe there's some algorithm there that you can find useful. I don't know. Maybe you're probably finding checking if a number is prime is probably a very specific algorithm there. But I mean, maybe just check the stood parallel algorithms and see if anything can be of use there.
I guess my main.
In fact, yes. I guess you could use the standard algorithms with the execution policy of par unsec, which is parallel and unsequenced, which tries to do it parallelly as well as use the SIMD. And I guess all you need is, for example, so I'm thinking dumb here. If you have a list with 1 to 1 million in a list, all you're doing is remove copy if into another list of prime numbers. So you leave out some, and so you do the same algorithm on every number on the left hand side before you copy it on the right hand side. But I guess you can get smarter with some generate doing this thing, or I guess there are other algorithms I guess which can be used.
Trying to I'm not very good at explaining myself. The problem is not that I'm not utilizing my CPU to 100%, right? I've created 4 threads. I've split the data across all of them. I'm consistently using 100% of my CPU. What I'm looking into is that if I can use my GPU to accelerate to, like, instead of using 4 cores of my CPU, 4 cores of my CPU plus the 10 or 20 cores that the GPU provides me, right?
Yeah. So okay, so
Yeah.
that's going to be a separate problem.
I think you can use GPUs.
Yeah, you can.
Kind of.
You can do it. I think so. There was a initiative also. I don't remember the name actually. Open AMP or something. For this heterogeneous processing architecture, where you can just write code once, like that was their goal, that you write code once and then let the platform take care of scheduling it across various heterogeneous architectures. But I don't know if it actually like how exactly mature it is, like with respect to software support.
There's a project called Sickle, which is a chrono specification, which is the same that specifies OpenCL and Vulkan and whatnot. And
Yes.
they have their own open source implementation, and one company, CodePlay, also provides a proprietary implementation and whatnot.
So we had a presentation on task flow by the author of task flow. I forgot his name. So that also allows you to create and have tasks to be run on the GPU.
Yes. Yeah, I just remember now that one. So even there's a task flow library there where it does most of the hard work for you of scheduling your application across multiple devices and heterogeneous cores.
Does that work on AMD? Because I don't have an NVIDIA GPU.
Okay, I don't remember the project name actually. They had a very
on GitHub it is. Yeah, if you hit task flow on Google, that is the first link to come up.
Yeah.
Task
flow would be much more simpler to go that route. I think so. Like the way, like a much more simplified design in terms of use. So there is, I think, so one more initiative by Intel also. They have that one API thing, but I don't know. They released it this year only. That you have only one API for your computers and let the backend platform take care if you want to run it on FPGA or a GPU or a CPU, whatever. But I think so. It still needs to be adopted by people to actually have some kind of traction going. So
are you referring to Intel TBB, thread building or thread basic blocks?
No, not that. They have recently announced, I think so, or it's still in beta, I don't know. So there is an initiative called One API.
Oh, I saw that. Okay.
Yeah, so they are basically targeting like having only a single API structure for instead of like if you look at from GPU perspective, we have CUDA, which is from NVIDIA. Then like there is an industry standard for OpenCL and OpenGL and a lot of different, and now Vulkan is also there. So a lot of different standards are there, but they have their own interfaces. So with Intel, they're trying to say that we just have one API for different backends. So let the software stack take care of doing all the hard work for you for like if you are targeting an FPGA. So if you have an initial design which you want to just do, uh, you know. Just evaluate how well it performs. You can do it on FPGA. So now you get AWS FPGAs also, and other stuff. So yeah.
Thanks a lot.
All right. So I had something to ask regarding the compilers. So has anyone been using compiler sanitizers?
I have.
Yeah.
Uh,
Yes.
has anyone used it with Visual Studio?
No.
Yeah, that is the main concern because
Z++.
Actually, I'm on Linux, so I use GCC with fsanitize, and I mainly use thread sanitizer and address sanitizer because those are the main things that I use.
yeah, those are the, I guess, main things that I use, but those are simply, or let's say fairly easy to use in GCC and Clang, but not so well built or mature with Visual Studio. So we were trying to do some exploration in this direction, but unfortunately Visual Studio just released a stable version of its address sanitizers, but those sanitizers aren't even capable of basically detecting memory leaks. So usually you would expect leak sanitizers to be part of the address sanitizers, because that is the case in GCC and Clang, but so is not the case in Visual Studio. So this exploration kind of went a bit
So,
in a
so
failure.
what version of Visual Studio you're using?
The latest one, 2019.
So I thought it has support for C-line compilers. Like from
Yeah,
2017, Visual Studio has integration with C-line, but okay,
yeah.
I don't know about the sanitizers perspective. I'm not sure if the Windows
I was going to
platform.
say the same that you can get Clang for Windows. I guess even if you don't use Visual Studio entirely, you can just use a different editor for web sanitizing purpose and launch Clang from the command line because Clang has builds for Windows. But
Mm-hmm.
I don't know the status of the sanitizers. I don't know if they will work on Windows.
Mm-hmm. Yeah, so basically we were trying to do the exploration on the three compilers, GCC, Clang, and Visual Studio. The only issue that we face is from this Visual Studio side, where MSVC is not so mature. And the thing is that you can enable the sanitizers, by the ID and everything, and things work fine. But when you pass that fsanitize flag by your CMake files, then you need to do some additional inputs, like there's this file in Visual Studio called cmake settings.json, which it uses for its CMake related integration. So there you need to basically add one parameter like enable address sanitizers. So this kind of hard coded things are needed to be enabled, and then basically you need to also link your that Clang built library of Visual Studio, which basically provides you this address sanitizer facility, so that finally your address sanitizers are enabled. So this is not really the clean way as GCC and Clang have been providing. So I wanted to know if someone has a better experience with Visual Studio on the sanitizers.
Are you or your company using some kind of CI/CD?
Yeah. So that is the reason that we want to, in locally we have the possibility of doing it via the ID, and things work fine. But when we want to pass it via CMake or any build system, basically, I would say then we face these issues.
Yeah, because I was going to say that if you have some kind of build system in place, then you can just most build systems I guess will be based on Linux, so you can just use Clang and GCC whatever there.
Yeah, yeah. We have some limitations, and at the moment we are trying to basically remove them. But yeah, we mostly do our development work on Visual Studio. So.
The reason I left Windows was because with Visual Studio experience was not ideal. That's the reason I started using Linux because especially like C++ is still good. If you want to do C in Windows, it's like hell because Visual Studio is basically the only supported compiler, and its support for C is basically out of the window. And yeah.
I
Yeah,
don't know what particular use case you are targeting. Like if you are building a Windows application, you got no choice. But I would say that if you can try Linux in a Windows, like Linux in a virtual machine or something, that experience will be much better.
yeah. So we actually have that possibility. One of the reasons that we don't use the Linux platform completely is basically we have some legacy code which uses the Windows specific things related to threads and everything, which we are trying to clean up so that we make it platform independent, and probably then we might shift things to the different platforms as well. Yeah.
So one thing is that you were saying that you need to edit some config file for the Visual Studio, right?
Yeah.
For enabling it.
Hmm.
So you could actually just add a like a post build target in your CMake or something, and maybe run some kind of Python script which can edit the config file for you. So
Yeah.
like I usually do it that way, so that because anyway CMake is generating the solution for you, the Visual Studio project.
Hmm.
So you can just add it as a like a post build command or something which can run the script and just find the file for you, the CMake whatever file you mentioned, right? CMake
Yeah.
settings. So
Hmm.
you can just add it to that thing. So I think you can. That's the usual way like I tend to do it because
Yes. Yeah, that is also so one of the things that, yeah, I guess that can be done, but the reason here is another thing that once you enable this sanitize flag via CMake, via doing this configuration and everything, even then you would get a linker error. So the compiler would know that the sanitizers have been enabled, but it wouldn't be able to file the actual DLL that it uses for the address sanitizers, which is something like clang.rt.asan, some sanitizer library that basically Visual Studio uses. So then also you need to basically link to its static library, provide its path and everything. So there's a lot more of configurations and heavy work
uh,
that needs to be done for the setup. Yeah.
I think CMake might have support for adding those kind of flags
No,
for
yeah, that is also one issue that at the moment CMake doesn't have it. It provides something regarding Xcode and something for the sanitizers enablement, but regarding
Yes,
MSP.
so you could actually add a custom target, like custom target in CMake,
Yeah,
which can add those command line flags as well as the linker and other
yeah,
settings.
yeah, 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 yeah. Basically, yeah. These types of configurations, I guess, yeah, can be done and enabled, but since the same topic is much easier to use in GCC Clang, so I wanted to know if someone had found a fix or an alternative way of, a much easier way of basically doing it directly via your CMake scripts.
Actually, I am attending the ACCU conference, and there was a talk by Victor on the address sanitizers on Windows. But I don't attend it because I work on Linux.
Hmm.
So once the recording will be out, you can see it.
Yeah. Yeah. Thanks.
So we'll be wrapping up in a couple minutes.